In the battle for the final frontier, two superpowers clashed in an epic race that would shape the course of human history. Brace yourself for an adrenaline-fueled journey through the dramatic saga of the space race. USA versus USR. Join us as we unveil the gripping stories of pioneering astronauts, groundbreaking missions, and audacious feats of engineering that propelled these nations to defy gravity and conquer the unknown. Get ready to witness the triumphs, the setbacks, and the extraordinary moments that defined an era and forever changed our understanding of what it means to reach for the stars. The space race was a 20th century competition between two Cold War rivals, the United States and the Soviet Union, to achieve superior spaceflight capability. It had its origins in the ballistic missile-based nuclear arms race between the two nations following World War II. The technological advantage demonstrated by spaceflight achievement was seen as necessary for national security and became part of the symbolism and ideology of the time. The space race brought pioneering launches of artificial satellites, robotic space probes to the Moon, Venus, and Mars, and human spaceflight in low Earth orbit, and ultimately to the Moon. Origins. Although Germans, Americans, and Soviets experimented with small liquid fuel rockets before World War II, launching satellites and humans into space required the development of larger ballistic missiles such as Wernher von Braun's Aggregate 4, A4, which became known as the Vergeltungswaffe 2, V2, developed by Nazi Germany to bomb the Allies in the war. After the war, both the US and USR acquired custody of German rocket development assets, which they used to leverage the development of their missiles. Public interest in spaceflight was first aroused in October 1951 when the Soviet rocketry engineer Mikhail Tikhonravov published Flight to the Moon in the newspaper Pionirskaya Pravda for young readers. Missile race. Soon after the end of World War II, the two former allies became engaged in a state of political conflict and military tension known as the Cold War, 1947 to 1991, which polarized Europe between the Soviet Union satellite states, often referred to as the Eastern Bloc, and the states of the Western world allied with the U.S. Soviet rocket development. The first Soviet development of artillery rockets was in 1921 when the Soviet military sanctioned the Gas Dynamics Laboratory, a small research laboratory to explore solid fuel rockets, led by Nikolai Tikhomirov, who had begun studying solid and liquid-fueled rockets in 1894 and obtained a patent in 1915 for self-propelled aerial and water surface mines. American rocket development. Although American rocket pioneer Robert X. Goddard developed, patented, and flew small liquid propellant rockets as early as 1914, he became a recluse when his ideas were ridiculed by an editorial in the New York Times. This left the United States as the only one of the major three World War II powers not to have its rocket program until von Braun and his engineers were expatriated from Nazi Germany in 1945. Soviet planning. On August 30, 1955, Korolev managed to get the Soviet Academy of Sciences to create a commission whose purpose was to beat the Americans into Earth orbit. This was the de facto start date for the space race. The Council of Ministers of the Soviet Union began a policy of treating the development of its space program as top secret. When the Sputnik project was first approved, one of the immediate courses of action the Politburo took was to consider what to announce to the world regarding their event. The Telegraph Agency of the Soviet Union, TSS, established precedents for all official announcements on the Soviet space program. Sputnik. Korolev received word about von Braun's 1956 Jupiter C test and, mistakenly thinking it was a satellite mission that failed, expedited plans to get his satellite in orbit. Since the R-7 was substantially more powerful than any of the U.S. launch vehicles, he made sure to take full advantage of this capability by designing Object D as his primary satellite. It was given the designation D to distinguish it from other R-7 payload designations A, B, V, and G, which were nuclear weapon payloads. Object D dwarfed the proposed U.S. satellites, having a weight of 1,400 kilograms, 3,100 pounds, of which 300 kilograms, 660 pounds, would be composed of scientific instruments that would photograph the Earth, take readings on radiation levels, and check on the planet's magnetic field. U.S. response. CIA assessment. At the latest, the successful start of Sputnik 2, with its weight of more than 500 kilograms, proved that the USR had achieved a leading advantage in rocket technology. The dumbfounded CIA estimated the launch weight at 500 metric tons, requiring an initial thrust of more than 1,000 tons, and supposed the use of a three-stage rocket. In a secret report, it concluded that the launching of 2 Earth satellites must have been a stupendous scientific achievement. Launching of these satellites does indicate, however, that the USR has perfected an ICBM which they can put on any desired target with accuracy. In reality, the launch weight of the Soviet rocket was 267 metric tons with an initial thrust of 410 tons with 1.5 stages. The CIA's misjudgment was caused by extrapolating the parameters of the U.S. Atlas rocket developed at the same time, launch weight 82 tons, initial thrust 135 tons, a maximum payload of 70 kilograms for low Earth orbit. Creation of NASA. On April 2, 1958, President Eisenhower reacted to the Soviet space lead in launching the first satellite by recommending to the U.S. Congress that a civilian agency be established to direct non-military space activities. Congress, led by Senate Majority Leader Lyndon B. Johnson, responded by passing the National Aeronautics and Space Act, which Eisenhower signed into law on July 29, 1958. This law turned the National Advisory Committee on Aeronautics into the National Aeronautics and Space Administration, NASA. It also created a Civilian Military Liaison Committee, appointed by the President, responsible for coordinating the nation's civilian and military space programs. First humans in space. Vostok. The Soviets designed their first human space capsule using the same spacecraft bus as their Zenit spy satellite, forcing them to keep the details and true appearance secret until after the Vostok program was over. The craft consisted of a spherical descent module with a mass of 2.46 tons, 5,400 pounds, and a diameter of 2.3 meters, 7.5 feet, with a cylindrical inner cabin housing the cosmonaut, instruments, and escape system, and a bionic instrument module with a mass of 2.27 tons, 5,000 pounds, 2.25 meters, 7.4 feet, long and 2.43 meters, 8.0 feet, in diameter, containing the engine system and propellant. After re-entry, the cosmonaut would eject at about 7,000 meters, 23,000 feet, over the USSR and descend via parachute, while the capsule would land separately because the descent module made an extremely rough landing that could have left a cosmonaut seriously injured. Mercury. The U.S. Air Force had been developing a program to launch the first man in space, named Man in Space SUMIST. This program studied several different types of one-man space vehicles, settling on a ballistic re-entry capsule launched on a derivative Atlas missile and selecting a group of 9 candidate pilots. After NASA's creation, the program was transferred over to the civilian agency's Space Task Group and renamed Project Mercury on November 26, 1958. The Mercury spacecraft was designed by the STG's chief engineer, Maxine Fadjet. NASA selected a new group of astronauts, from the Greek for Star Sailor, candidates from Navy, Air Force, and Marine test pilots, and narrowed this down to a group of 7 for the program. Capsule design and astronaut training began immediately, working toward preliminary suborbital flights on the Redstone missile, followed by orbital flights on the Atlas. Each flight series would first start unpiloted, then carry a non-human primate, then finally humans. As the dust settled on the battlefield of the space race, a legacy was forged that forever transformed our understanding of the universe and our place within it. The rivalry between the USA and the USSR ignited a fire of innovation, pushing the boundaries of human achievement to unimaginable heights. Their relentless pursuit of space exploration propelled us from the confines of Earth into the vastness of the cosmos. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.